Everyone, and welcome to lesson 22.2. Today we are going to start a little bit into the lesson on page 306, and you'll definitely want a pencil to look at and possibly your calculator for reference a little bit later. Now, at the bottom of page 306, we see two different right triangles, and in any right triangle, the hypotenuse is opposite of the right angle. We've talked a lot about this with Pythagorean theorem because that is always our C value for A, B, and C. For the other two angles inside of our right triangle, they are acute angles. And reminder that acute angles are less than 90 degrees, right? Acute means that they are smaller than 90. And that's what the other two angles have to be. In this case, angle C and angle A are both going to be acute. If you pick one of these angles, there is a side opposite of one of the acute angles, and the remaining leg would be known as the adjacent. Another word for adjacent, again, means next to, right? It's been a while since we've talked about this vocabulary word. So if we look here at the triangle they're giving us, if we are looking at angle C, okay, that's our reference angle, we'll call this angle C. We have the hypotenuse still is AC. So this is still our hypotenuse. But then the side that is going to be called the opposite leg is the side across from angle C. So this would be the opposite. And then the adjacent leg would be the one next to it. So this is the other leg that we would then call the adjacent. Now that would flip-flop for angle A, okay, if we flip-flop this around. So imagine now instead of talking about angle C, we're talking about angle A. Now the hypotenuse is still going to be the hypotenuse, right? Oops, I forgot an O in hypotenuse. The hypotenuse is still the hypotenuse, right? It's still across the right angle no matter what. But this time for acute angle A, the opposite is going to be CR, and the adjacent would be, again, the side next to angle A that's not the hypotenuse. This would be your adjacent. So it's very important to circle and recognize what angle you're talking about when you are labeling opposite and adjacent. Okay. So in number 7, again, if we're looking at now triangle bus, we are going to look for angle U, right? So we're going to circle angle U. And again, we know the hypotenuse is here, so we'll still label that. And the opposite leg of angle U then is the one across from it. So in this case, that is SB is the opposite, and the adjacent then is the leg that is next to it, and not the hypotenuse, but still next to it. This would be your adjacent leg. Okay. Now, where all this is leading us is to start setting up labeling in our pictures so that we can start looking at our calculator and using these 3 buttons. Notice here we have sine, we also have cosine, COS is what our abbreviation is, and tangent, right, which is represented by tan. And these 3 values, sine, cosine, and tangent, are going to represent certain setups. So we have sine, we have cosine, and we have tangent. Okay? And in these 3, they're all going to be dependent upon some right angles. Okay? So if we have a right triangle here, and let's call this triangle A, B, C, if we are talking about angle C as our reference angle, we're going to want to concern ourselves with the opposite side of angle C and then the hypotenuse. And that's what we see set up here, opposite and hypotenuse. For cosine, if we use the same right triangle, if we called this A, B, C, and again, we were representing angle C as our reference point, we would want the adjacent side and the hypotenuse. And then for tangent, it's going to involve our opposite side and our adjacent side. So in this last one, we would have A, B, and C as well. Okay, and again, if we're looking then at angle C again, we would concern ourselves with the opposite side of angle C and the adjacent side to angle C. Okay. So we will be working more with these moving forward, but the important piece of today is being able to identify those pieces based on an acute angle, which is the hypotenuse side in our right triangle, what is opposite of the angle in question, and what is adjacent to the angle in question, being able to identify those legs. Okay? We will work more with this and sine, cosine, and tangent in the upcoming lesson. Thanks, everyone.